There are two kinds of radiation astronauts must contend with in outer space: solar flares and cosmic rays. Solar flares are floods of protons that burst from the sun at irregular intervals and would be dangerous to an unshielded human crew.
We are not ready to send humans to Mars right now. We've got to know a lot more about radiation and radiation mitigation. One of the Apollo flights barely missed, like by a week, a major solar event. If it had gone off when the Apollo astronauts were on the way back and forth to the moon, they would have gotten their entire lifetime radiation dose in that one mission. And that's just one solar flare. So that's why we worry about this.
In the Mars Direct plan, Zubrin envisions a central, insulated core where a crew can retreat to while the radiation passes by. The core would be surrounded by all the provisions of the mission. This should stop any harmful dose of radiation from reaching the astronauts.
Basically, you use your pantry as your storm shelter. So a solar flare happens, the alarm bell rings, the crew goes into the storm shelter, they stay in there cramped up pretty tight for a few hours until the all clear rings and they come out. This is going to happen once, it might happen twice in the course of the mission.
The second type of radiation is cosmic rays. This constant rain of charged particles comes from interstellar space and cannot be avoided without many meters of shielding. We can experience some of this type of radiation on Earth at high altitudes. Airline pilots who spend their careers flying high in the atmosphere can receive almost as much of this radiation throughout their life as a Mars astronaut would on a 2.5-year mission.
It's a long trip. It's a 6-month trip there, a 6-month trip back. It's probably a year on the surface. That's a lot of radiation.
The best estimates are that the magnitude of that dose is not that great, perhaps 60 rem of radiation scattered over 2.5 years. Now, 60 rem of radiation delivered over a long period of time like that would not create any noticeable effects at all. It would, though it is believed, increase your statistical risk of getting cancer at some point later in your life by about 1%. Right now, if you're an average American and you do not smoke, you have a 20% chance you're going to die of cancer. This would make it 21. If you're an average American smoker, it's 40. So in fact, if you recruited the Mars crew out of smokers and sent them to Mars without their tobacco, you would be reducing their chance of getting cancer.